Okay, we're back with more torque practice problems for practice 2. We are looking at 2B this time, so same setup as 2A, but we care about the worker here, highlighted in yellow. And in this problem, we're looking at the worker. We know that the worker is applying a force here straight up of 45 pounds. And we know that this rod here, this beam, is pivoting back here at the orange point. This is the pivot. So if this is the pivot and our force is way out here at the end, that means that this entire distance going across, poorly drawn as a straight line by me, is the moment arm. And the entire length of this steel beam is 12 feet long. So if we once again look at torque, we know that torque equals R cross F, which is R times F times the sine of theta, the angle between them. So in this case, we have R and F. R is 12 feet. F is 45 pounds. So there's our foot-pounds. And now we need sine of that angle, whatever it is. In this problem, we know that down here, this angle is 30 degrees. So you may want to put in a 30, but that would be wrong. What we want to do is we want to redraw this by translating the force back to the pivot. So if here's our pivot right here, we have the moment arm going up like this. This is R. And our force vector is acting straight up. This is F. And we want the angle going R cross F. So we want to go from the R vector to the force vector. That's the angle we want. Well, the only thing we have in this problem is that this angle underneath here was 30 degrees. And if this is to be a right angle, then that means the complementary angle there has to be 60 degrees. That's what we want. So we can say that our angle is 60 degrees here. So 12 times 45 times the sine of 60. 12 times 45, making sure we're in degrees, times the sine of 60, gives us a value for our torque of 467.6, so let's just say 468 foot-pounds rounding up. And there it is. If we want to get an idea of what the direction of this torque is, if this person is lifting this beam up, the beam is rotating this way. You can imagine lifting it up and tossing it over. This is a clockwise direction. Mathematics, clockwise is negative. And if we want the direction of the torque itself, if we take our fingers, our 4 fingers, and we rotate them in a clockwise direction, and if you're looking at a screen, you may have to chicken wing your arm like this to get your fingers to rotate, or kind of hold it like this. Or if you're looking at your paper, you may have to chicken wing your arm. You'll notice that your thumb is pointing either down into the paper or into the screen, however you're doing that. And if our arm is pointing into the screen, then that means that the torque is into the page or into the screen as well. So our directions of the torque are into the page or into the screen. They're clockwise, and that is a negative direction. So that's how we find directions of the torque there. So I hope 2B went well for you. I hope you understand that. If you need anything, reach out to me. In the later problems, it's the exact same idea what we've seen here, looking for a moment arm, a force, and an angle. It's just a little bit more geometry to find out what those angles could be later on. Take it easy.